So this set of notes is on arithmetic sequences that we did today, the first day of the new semester. So arithmetic sequences. And today in class, we just practiced doing pattern problems was what our classwork was on. But one of the types of sequences or patterns that we're going to be seeing is this arithmetic sequence. So I just want to make sure we kind of start the notes on this and eventually geometric sequences another day so that we have those in our notes. So arithmetic sequence. And an arithmetic sequence is generated by adding or subtracting the same number. So generated by adding or subtracting the same number. Okay. And I'm going to talk about the type of graph. So this is the graph. If I was to graph this, this is going to be a linear graph, a line, and it is going to be discrete. That means we don't connect it. We just plot the points, but we don't connect the points with a line. So example. Okay, so an example would be if we have 3, 8, 13, 18, ... Okay, for this sequence. And so we're trying to figure out what are we doing every single time. So in this case, I'm adding 5, I'm adding 5, I'm adding 5. So I am adding 5, okay, and that's why this is an arithmetic sequence. And when I'm adding 5, let me just get this focused a little. So again, in this, I'm adding 5, adding 5, adding 5. So that's why this is an arithmetic sequence. And we call that the constant difference. Constant difference. Okay, and again, today we didn't actually have to do any of this, but I just want to start the notes. And so we call that D, and we're going to say D is equal to 5. And it's a positive 5 because I'm adding 5. If I was minusing 5, I would have put a negative 5 here. Now, when we have a sequence, the easy way to kind of denote where we are in a sequence is to do the following. So let's say I say f of 1. F of 1 means what is the first number in the sequence? 3. So again, this is first number in sequence. That's what that f of 1 means. So the 8, for example, would be f of 2. So f of 2 is our second term, and my second term is 8. And kind of as an example, if I was talking about, let me just grab a pen here. If I was talking about this 18 here, okay, this 18 here, if I was talking about 18, that would be my first, second, third, fourth term. So f of 4, for example, would be 18 because that is my fourth term. Now, just a little note. A lot of times we think about the start, and the start is our 0. In this case, this is not our 0. It is our 1. So we got to be careful. So a little note. 3 is not our 0 term. It is our first term. And when I say first term, what I mean is it is our f of 1, not our f of 0. So this would be our 0 term. So if I wanted our 0 term, because usually we like to know our 0 in order to write our equation. So if I wanted to know, hey, what is our f of 0? Our f of 0, Well, I need to go backwards. So I'm adding 5 going this way. Going backwards, I'm subtracting 5. So I would be getting a -3. And again, I would have taken my 3 and minus 5, and that's how I got my -2. So this is my start that we're used to. This is our 0. This is what we're going to use to help us write one of our equations, which we're going to call explicit equation. So we have two types of equations for this. One's called recursive. We actually saw this in our review. Okay, recursive for our final exam. Usually we cover this in first semester. This year we did not, but it was still on the review worksheet. We didn't have it on our test though. Recursive equation. So recursive equation, f of n, okay, where n is the term I'm trying to find. So like f of 0, maybe I'm finding f of 4, the fourth term. So if I wanted the fifth term, for example, I know the fourth term is 18. I know I'm adding 5, so I'd add 5 onto the fourth term to get the fifth term. That's what this recursive formula is. So if I wanted to know the nth term, that means I'm going to take the term before that, which would be n minus 1, and then I'm going to, in this case, add 5, because that's what we're doing. So again, what I could have done up here was, since this one is f of 4, I'm going to, if I want to find my next one, which is f of 5, I'm going to take my fourth term, 18, add 5. That's all that this is saying. So we use this recursive to find next term. That's when we use this. So if I wanted to find the fifth term in that sequence, I would use recursive. If I asked you for the 100th term in the sequence, I would not use recursive. I would use explicit. Because if I was using recursive, I'd have to keep adding 5, adding 5, adding 5, starting here, in this case, with my fourth term, all the way to my 100th. And that's a lot of work. So we want a way that we can just put 100 in for the 100th term and figure out what it is. And we call that an explicit equation. And for the explicit equation, we're going to start with our start. Oh, and something I need to add in here is that when we're doing this and we're doing our recursive, we do need to know what we're starting with. Okay, just a little note. We'll get it more into this when we start dealing with these equations a little more. But if I saw this, I would know the pattern is add 5. But like the one on our review for our final, they gave us an equation like this, and they gave us a first term, and they said, okay, find the rest of the sequence. And we could just keep adding the 5. But in this case, if I didn't see the equation, I wouldn't know what to start with. So usually we would say, hey, f of 1 is 3. And that tells me, hey, we're going to start with 3 for our first term, then add 5. Okay. Now for this one, if I want the 100th term, I'm going to start with f of n, just like I did here. And this time what I'm going to do is I'm going to start with my 0 term. My 0 term is -2. This is my f of 0. I'm going to start with my f of 0 here. Let me get that in the screen a little better. And then what am I doing to that? I'm adding 5. Once, twice, 3 times. In this case, n times. So I'm starting with my 0, and then I'm adding 5 over and over and over. And that's my recursive formula. So if I wanted to find my 100th term, I would stick 100 in here, and I would get my answer. So if I was doing this on my calculator, and I'm starting with my -2, and I'm adding 5 100 times, I would end up with 498 as my answer. Okay. Now, the last thing I'm going to add in here, we didn't do this in class, but I'm going to add it into the notes so it's on there for those who need it next time, is the graph. So if I wanted to graph this again, graphing this, I would plot the points. So let me just rewrite these points here so we see them. Okay, let me just grab something to write. Okay, so my sequence was 3, 8, 13, 18, ... Okay, that's my sequence. I'm going to do my graph here on the side, okay, just to give myself some more space. And so when I'm drawing this, let me kind of raise this up so you can see where I'm ending. Okay. And so when I'm doing this, this is going to be my sequence number or term in sequence, and this is the value, okay, the number that's in that. So I'm just going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, let me just graph up that high. So if I'm graphing the sequence, I'm going to take my first term in the sequence, which is 3, and I'm going to plot 1, 3. So I plot 1, 3. First term is 3. My second term is 8, so I'm going to go 2, 8. Okay, so again, this is 2, 8. And then my third term is 13, so I'm going to go 3, 13. So 11, 12, 13, and so on. And again, we don't connect it. And this is going to be a linear, discrete graph. Okay. So hopefully this helps for anyone who was having some internet issues today and maybe wasn't able to get all the notes down.